Welcome to the video tutorials of the book Methods, Evaluation and Research in Education by Mohammad Aktaruzzaman. And today we're going to learn how to do regression in SPSS. Regression is a method of correlation for computing the most probable value of one variable from the known value of another variable, which is also a method for computing the amount of change in one variable for a unit change in another variable. The general equation for regression is y equal to ax plus b, where x is the predictor for estimating y and on the other hand ab are just simply constants. Regression analysis is widely used for explaining variation in market share, sales, brand preference and other marketing results. For example, can variation in sales be explained in terms of variation in advertisement? Let's go through an example. A researcher wants to predict the achievement score based on the IQ score of a group of 14 students. The IQ test score and the achievement score are kept in a file, regression. Considering this scenario, now we're going to formulate the regression equation and predict the achievement score based on the IQ test result. Let's see the SPSS data editor window at the screen. Now, go to the File menu, then open Data, and then Data File under SPSS Evaluation folder, and open the file Regression in the SPSS data editor. The file is shown in SPSS editor in the data view. Let's check the variable view of the data. There are three variables, achievement, IQ, and hard work, which are of numeric type and scale measure. Now, go back to the data view of the SPSS data editor. You see the variables at the top of each column. See the scores of 14 students for achievement test and IQ, and also hard work in terms of study period in hour. Go to the Analyze menu now, then Regression, then Linear. Take the score of the examination in the dependent field and IQ score in the independent field. Now, click Plots button and take the Z-receipt, which is residual in Y, and Z-pred, which is prediction in X. Also select histogram and normal probability plot. Residual, which is Z-receipt, is simply the difference between the actual value and the predicted value. Click Continue and then press OK. See the output at the screen. The R value 0.702 indicates that a positive and moderate relationship exists between IQ score and achievement of the student. It implies that if the IQ score of a student is good, he or she will do good in the achievement test. Wow, that's great. The adjusted R-square value 0.450 indicates that 45% of the variation in achievement can be explained by the variation in IQ score. In SPSS interpretation, sig value greater than 0.05 means acceptance of the null hypothesis, and on the other hand, sig value less than 0.05 means rejection of the null hypothesis. The details of it are described in chapter 10 of the book. The sig value of regression 0.005 at the ANOVA table is less than 0.05, which implies the null hypothesis, which is the IQ score of a student has no significant role to predict his achievement, is rejected. That means research hypothesis is accepted. So, the IQ score have a significant role to predict the student performance. The value of constant B is 12.101 and constant A for IQ score is 2.532 at the coefficients table. So, the regression equation stands y equal to ax plus b, which implies to y equal to 2.532x plus 12.101. However, the sig value for constant b 0.030 is less than 0.05, which means the factors, constants, excluding IQ score have significant role to predict the achievement score. And also the sig value of constant A in IQ score 0.005 is less than 0.05, which means that IQ score has also significant role to predict the student's achievement. Now, using the equation y equal to 2.532x plus 12.101, you can easily predict the achievement of any student based on his IQ score. In case of residual, the histogram shows an ideal normal distribution. The normal PP plot shows all the points on the diagonal, which means the residuals are normally distributed, and the scatter plot shows no pattern, confirming the linearity of the relationship. You may have noticed that during the calculation of regression, you are also getting the correlation. So, it can be said that regression is 2-in-1. Wow, that's great. You can practice yourself on different datasets and have a good understanding on regression. Thank you for staying with us. It's Yazdani saying you goodbye.